Okay, so I'm going to show you how to use the cross-section viewer, and you'll be doing this in the homework, and there should be kind of step-by-step in the homework, but I will demonstrate a little bit of the functionality of the software right now. So first of all, I am going to show you how to download the cross-section viewer. Just go to Google, cross-section viewer, and North Arrow Research is the right company, so this is the right cross-section viewer. There's various other things, cross-section editors, cross-section viewers, but North Arrow Research, it's the top result for me anyway. And this is a helpful website. It's got various helps and explanations and some documents. I'm going to click on download. And if I have admin rights, like I'm doing this on my own computer, then I can click cross-section viewer download, and it will download a file that is called setup, and then I'll run that setup file and it'll download and install the cross-section viewer for me. If I don't have admin rights on the computer, like I want to work on a school computer, you can actually still download it even without any admin rights, but you have to use a different method. So this one called manual installation, and this second method was developed because on the Corps of Engineer computers, we don't have admin rights. And so we wanted a software to download and use that we didn't actually have to install. And so this other method was developed. So you can then go to this manual install and download the zip file and follow directions. It'll tell you what to do. If you want to install it on a school computer to use, you can do that. All right. Once I've got it installed or downloaded and I open it, then it'll give me this screen here, and I'm just going to close out, and then I'm going to say open database, and you can open the database which I have provided with you. I've provided a .xsdb, so cross-section database, for you to use in this homework. And so I am opening that one. And then under Tools, Plot Cross-Sections, I've got now a list of surveys. These are various Missouri River surveys. And I've got a list of cross-section selections, so sets of surveys of sets of locations. They're kind of query data sets. And I've also got a list then of cross-sections. So these are all different cross-section numbers that have been collected at some point. So if I, for instance, go to the selection that is all 1994 locations, which I've created that selection data set already, and I have 1994 selected. Every single one of these is going to have a cross-section because I made this data query, this selection set earlier. So this is data from 1994. If I hold down Control and click on 2009, for example, now I can get a second cross-section. Well, it's the same location, but it's an additional year of 2009. And then I'll do it again here for 2000, let's say 2013. So what we can see at this location is 1994 and 2009. It looks like between 94 and 2009 the bed degraded, mostly in the Thalweg. And then between 2009 and 2013 the bed degraded quite a bit, mostly in the Bar area. So we can see that. We can also see differing extents of the data collected from one year to the next year. So I could now just click on a different year and it'll keep my same survey years selected, or click on a different location. And I can see that. If I want to see all the data at that location, I can click on one and shift click, and it'll select all of them. Now in this case I have this 2014 LiDAR data. These are cross sections that we struck from LiDAR, and LiDAR collected by plane and gives you returns that are on the ground, but it pings off the water surface. So this flat surface here is just the water surface on the day that the LiDAR flew. But you can see the overall cross section, and we only have data here for the bed of the cross section. So I'm going to Control click on the LiDAR data to deselect it so I can see better the rest of the data. So there's a lot of data in this location, and and I can do math on this data. But the first, most important thing with the cross-section viewer is just you can view your cross-sections. You can look at, from one location to the next. You can also shift click cross sections, and you can view more than one cross section on top of each other, different locations. Usually that's not all that helpful. Usually what's helpful is clicking at the same location but looking at different years to see how things have changed. Oh, that's interesting. The deepest water that, there in 2009 shifted over in 13. And let's see, in 14 it stayed in that shifted over location. So that is the plotting cross-section tool. If I go to tools, actually if I go to data and I just say cross sections, this gives me a list of all the cross sections and which surveys included that location. So which survey years included that location. So I do sometimes look at this, but you can also do that just by looking at the cross sections themselves. All right, so now let's say I want to do some math. Let's start with the longitudinal cumulative volume change. So the longitudinal change tool is one of the most useful tools for saving time doing analysis. If I say my old survey is 1994 and my new survey is 2009, well actually data surveys 1994 has 1,812 cross sections, and 2009 has over 10,000 cross sections. But when I'm comparing, doing a volume change between 2 years, it's going to only find locations that exist in both surveys. And in this case, 2009 has a cross section at every location, and 1994 only has it at some. So when I do this analysis comparing 94 to 2009, there will be 1,812 locations that get analyzed. So more than 1,800 locations. Old survey 1994, new survey 2009. I want to only use the part of the channel that's common to both, as we talked about earlier, to be consistent in what part of the channel I'm analyzing. And I'm looking at volume change, and I'll hit update plot. And it's computing the area change at each cross section, and then it is using the volume math that I just showed you, multiplying the average area change by the distance between, and then it's accumulating that volume from upstream to downstream to compute this longitudinal cumulative volume change curve. And what we see here is the result of 1,812 cross-section pairs being analyzed. And we see from river mile 400 to, about, well, at river mile 500 to about, 420 or so, mostly stable, maybe very slightly aggradational, but then at about 400, the river was very degradational, degraded quite a bit. There's a little area where it deposited, and then a larger area where it generally degraded, another area where it deposited and then degraded, and a lot of degradation at the end. So overall, this river experienced about 120, or is that 1.2 million? About 1.2 million cubic feet of bed change. And I'm not positive if these units are correct, but if you go to data, actually export data, then we could see if the units there are correct. And if I wanted to know the bed change between any two river miles, the way that I do this is I would find, let's say between river mile about 200 and 300. I find the river mile of interest, and then I go over here and I see what is the value of the cumulative change at that downstream location, and it's about, it's about 900,000. And then at 300, it looks like it's about 650. So then I would take 900,000 minus 650, and that would tell me the resulting amount of bed change between those two river miles. Here, I'm gonna I'm going to export the data for a second. So you can see what that will look like. So the downstream river distance for any reach of the river, the downstream of that little bounding polygon is this downstream river distance. And then I've got the average bed change over the increment. I've got the average bed change just at that downstream elevation or cross section. So I'm going to just to show you, I'm going to plot this riverbed elevation change, and I use this feature all the time. This is how the riverbed average bed elevation changed at all the cross sections. So you see that this river is highly variable because of the sand dunes. Sometimes the riverbed's up, sometimes it's down, and so we have to average over longer distances to compute any useful information. But you can see, certain spots where it was more degradational than others, and then other spots it's a little hard to tell offhand if this whole thing was degradational or not, because there's so much scatter in the data. But if I plot that downstream river distance, and let's see here, I've got cumulative volume change, downstream river distance, cumulative volume change, and if I plot that, then it's much smoother. So that's one of the major reasons to look at cumulative volume change. Is now I can tell really well, and you see the axes are flipped on the upstream now is here on the right, how I plotted it in Excel. But you can see that this was pretty stable, slightly aggradational, but you can see where the areas were with the most degradation and areas with aggradation very easily. And then let's say I want to look at what was the bed change between, let's say, 496.8 and 487.17. If for some reason we were interested in these two locations. So what was the bed change? I'll take this number here and I'll just do this, equals whatever that value is minus whatever this value is, and this tells me what was the bed change between those two locations, and it's 8.4 million cubic feet. Okay, and this is cubic feet. So the other one that said thousands of cubic feet, that was correct. That was, should have been in the billions then, reading that graph overall. So this is telling me that the bed degraded between river mile 496.8 and 487.17, a total of 8.4 million cubic feet. And I can do that for any two locations on the river that I want. So that's very useful, very powerful. Okay, going back now, there are various bells and whistles. If I wanted to, instead of using the common lateral extent, if I wanted to go up to a given elevation, I can do that. I have to define those elevations as a reference plane, but there's different ways to constrain your analysis to make it do good analysis for you, to do what you want. All right, I'm going to click on compare cross sections just to demonstrate one more time this question about using consistent data. So if I am going, let's just pick a random cross section here. Old survey 1994, new survey is 2009. Let's pick a different one. It's not quite so messy. That's pretty messy. Okay, this one's good. So 1994, the old survey is in red. So in this case, the red one's 1994, and the new survey is 2009, and that's the green. So if I say use common cross-section extents, it's going to find the stations of this channel that have data for both surveys. So in this case, it stops this one right there, and then it stops this one right here, because the 1994 that's where the cross section stops, and so it excludes all of this other data out here, as it should. Otherwise, we're going to bias based on having data in one year that wasn't in the other year. Now, if I instead wanted to go up to an elevation, for instance, I could say original cross-section extents. Now it's using all the data that's in either survey, and my answer will be biased. But if I go up to a reference plane, and let's do a vertical offset. So let's say 5 feet. Actually, probably need to say minus 5 feet. Now it's given me this 5 feet below that reference plane, and it's truncating both of the cross sections at a vertical elevation. So maybe there would have to be like a real reason for doing this. But if this was, for instance, your 2-year flow, and I wanted to go, well, let's go 2 feet below my 2-year flow, or something like that, then I could go up to a consistent vertical extent. So this just helps you visualize what the different options mean, and what part of the channel gets included in the analysis based on the different options that I choose. Okay. So moving on now to look at the surface area. If I go to the reach area depth distribution here on surface area, and I'm going to pick a survey. Now, man, should we do the really big one? Well, let's start with, let's just do 1994. So and we'll go up to the water surface defined by the 2010 construction reference plane. So you can load different water surfaces in here, and then I am going to click compute, and that only went up to there we go, compute. All right. So that gave me the surface water distribution, or the total acreage that falls into these different depth categories. And based on those 1,800 cross sections. So it did that all very fast, as you can see, and it tells me that yeah, we've got some of this shallower water, we've got some of this deeper water, and I could compare different locations, different reaches, to look at how the depths are changing over time, or the prevalence of a certain type of habitat. And I can also do it as a percentage if I'm more interested in percentage, and I can do it looking cumulatively to say, well, depths less than a certain depth, what are the acreage, or what's the percentage less than a certain depth. All right, we've got the ability to create selections. So a selection, as I said, is it's like a query data set. So what if I wanted to do a selection set that was like river mile, 50 to 150? Then I could call it that, and I could say river distance between 50 and 150, and OK, and OK. And now I've got that selection set, and these are all the cross sections from my database that fall between 50 and 150. You will probably need to create your own selection set. The selection sets, even when you copy the database, they may not copy the selection sets, so you might have to create your own to start with. You could just make one called all. I'm going to call this all cross sections, and I'll go from 0 to 500, which all the data falls between 0 and 500, and set to all cross sections. And so it's looking through, and there's my set of all cross sections, and it all the locations from 0 to 500. If I wanted cross sections only in certain that only appear in certain surveys, or that do appear in those surveys, I could do that. If I want cross sections that have certain widths, I can do that. So this is also good for QA/QC to see if any of the cross sections were too small or were processed incorrectly. Some of these query tools were developed specifically for QA/QC. Okay, there's also ways to make new databases. So I can create a new database, and usually when I create a new database, I'll go to river distance because I'm looking at the river mileage, and I'll create a database and I can import data into that database. I explain how to do it in the tutorial, so I'll just let you run through the tutorial. But there are a lot of neat features in this software for analyzing cross-section data. And like I say, while working at the core, I would use this multiple times a week. Looking at data, exporting data, analyzing the data. So a very useful tool.